For millennia, the moon has fascinated humanity. We once took steps on its surface, a monumental leap beyond our world. Our technological journey has since seen incredible progress, making space exploration more promising than ever before. With the International Space Station nearing its end, a significant question arises. Could our next grand venture be building a permanent moon base? Numerous space agencies and private companies have already unveiled ambitious concepts for lunar outposts. NASA's long-standing interest in a moon base remains strong, yet political shifts and fluctuating budgets have kept it from becoming a top priority. Just 2 years ago, the European Space Agency revealed plans for a permanent lunar settlement in the 2020s, dubbed Moon Village. SpaceX also expressed interest, with Elon Musk suggesting in 2017 that we should have had a lunar base by now. Establishing a lasting moon base requires essentials like food, water, shelter, and ample oxygen for survival. Initially, this would necessitate transporting significant supplies from Earth. Compared to destinations like Mars and Venus, where interest is high, this would be more cost-effective. At approximately 384,000 kilometers distant, the Moon is our closest celestial neighbor. While it's our nearest space companion, the absence of conditions to support human life presents challenges. The Moon's lack of atmosphere exposes it to hazards from cosmic radiation and deadly micrometeorites. Extreme temperatures also pose a problem, fluctuating from 120 degrees Celsius during the day to -173 at night. A moon base could function as a strategic launchpad or a vital refueling station for future missions, offering significant cost savings compared to launching from Earth. Rockets would require less propellant for liftoff due to reduced gravitational pull, as the Moon's gravity is merely 1/6 that of Earth's. Furthermore, it would provide a unique environment ideal for scientific research and various experiments. Robotic rovers could be deployed to scout for optimal locations to establish such a base. They could also survey nearby resources, proving far safer and more economical than human exploration. However, it's noted that what a rover can accomplish in a decade, an astronaut might achieve in mere hours. A prime candidate location might be underground, within natural caves or lunar lava tubes, offering inherent protection from micrometeorites and harmful cosmic radiation. Japan's JAXA spacecraft Kaguya first identified an opening in the Moon's Marius Hills region back in 2009. Subsequent observations from NASA's Lunar Reconnaissance Orbiter revealed this feature to be 150 feet wide and deep, extending for 30 miles, which would certainly provide ample space for a base. Another advantageous location for construction would likely be at the lunar poles, areas where sunlight is nearly constant, and there's potential for water sources. NASA's satellites have already provided evidence suggesting the possible presence of water ice in permanently shadowed craters near the North Pole, areas that never receive direct sunlight. Additionally, India's upcoming Chandrayaan-2 mission is slated to orbit and deploy a rover onto the Moon's surface this year. If successful, Chandrayaan will mark the first mission ever to land a rover near the lunar South Pole, yielding crucial scientific data on lunar topography, mineralogy, and the signatures of water ice. Another valuable resource on the Moon would be helium-3, which is currently in short supply on Earth. Most nuclear power plants utilize nuclear fission reactors, where uranium nuclei are split, generating energy and radioactive waste. Helium-3 holds significant potential as a fuel source for future nuclear fusion reactors, offering the advantage of producing minimal radioactive waste. However, it's anticipated that such technology will likely not be available for at least another 50 to 100 years. One nation actively developing its space technology extensively is China, having publicly expressed its ambition to mine this resource. Nevertheless, the Outer Space Treaty, ratified in 1967, prohibits any nation from asserting territorial claims in space or on celestial bodies, asserting that space and all its contents are the common heritage of all humankind. This principle would surely be well received if we were to encounter another intelligent civilization. Presently, the primary justifications for space exploration involve launching satellites, making groundbreaking discoveries, and conducting scientific research. No entity currently possesses the technology for cost-effective asteroid mining or establishing a permanent colony, and only a select few billionaires can afford a journey around the moon. Once a company or government agency identifies a viable path to profit from space ventures, this long-standing Cold War treaty might face reevaluation or even be discarded. In the interim, however, a lunar base would likely function similarly to the International Space Station, a facility collaboratively built and utilized by spacefaring nations. Regarding the base's construction, solar panels would supply power and essential elements like construction materials. Communication systems would also need to be relayed from Earth, which would be a significant expense. Yet, companies such as SpaceX are pioneering novel and innovative approaches to reduce the cost of space travel, employing reusable rockets like the Falcon 9 and Falcon Heavy. The ESA is also actively advancing technologies in 3D printing, aiming to better adapt to the moon's unique environmental conditions. A lunar base could incorporate a communication hub, a dedicated research laboratory, and living quarters for its inhabitants. Once all systems are operational, a crew could be dispatched to conduct research and experiments, while also continuing to contribute to the base's ongoing development. Astronauts and researchers stationed at the lunar base would likely adhere to a routine comparable to that of the International Space Station. Crew members on the ISS typically remain for approximately 6 months, with a consistent presence of 3 to 6 individuals at any given time, though the American astronaut Peggy Whitson has accumulated an impressive 665 days in space. Astronauts cannot endure prolonged stays in space without consequences, as extended periods in low gravity lead to significant physiological changes in our muscles and bones. On average, astronauts lose over 1% of their bone mass for every month spent in space. Clearly, a full-fledged colony on the moon may not be practical, but a base for launching rockets and testing new technologies presents a promising future. Given its proximity, equipment and construction processes could be rigorously tested with minimal risk, providing invaluable experience and crucial insights before embarking on future endeavors to Mars and beyond. The potential for water ice, the reduced gravity, and the proximity make the moon an ideal testing ground for advanced technologies.